we have to show that the second partial derivative of f with respect to x equals a squared times the second partial derivative of f with respect to y, where f is a function of two variables and it's given by this particular expression. So let's begin. So we'll start with whatever we are provided with. So here we are given the function f, which is tangent of y plus ax added to y minus ax raised to the power of 3 over 2. We'll first take the partial of our function f with respect to x. That means we'll have to take the partial with respect to x of the tangent function. We have tangent of y plus ax added to partial with respect to x of y minus ax with raised to the power of 3 over 2. And we know that the derivative of the tangent function gives us the secant squared function. So here we have secant squared of y plus ax, which is obtained by taking the derivative of the tangent functions with respect to y plus ax. But we'll also have to use the chain rule, so we'll multiply it to the partial with respect to x of y plus ax. And this will be now added to. So here we'll have to apply the power rule. So here we have 3 over 2 multiplied to y minus ax whole raised to the power of 3 over 2 minus 1 times partial with respect to x multiplied to y minus ax. That is going to give us secant squared of y plus ax multiplied to partial of y with respect to x plus a is a constant, so we have a multiplied to partial with respect to x of x plus 3 over 2 times y minus ax raised to the power. So 3 over 2 minus 1 will be half multiplied to partial with respect to x of y minus a. So a is a constant here, so we've taken it out of the derivative. Partial with respect to x of x. So let's further simplify to get secant squared of y plus ax times, so partial of y with respect to x will be 0 because y will be treated as a constant whenever we're taking the partial derivative with respect to x. That is a, so we have a times partial of x with respect to x will be simply a. So this will be a. Fine. Plus 3 over 2 times y minus ax raised to the power of half multiplied to the partial of y with respect to x will be 0 minus a times partial of x with respect to x, that will be 1. So this is going to give us a times secant squared y plus ax minus 3 over 2 times a multiplied to y minus ax raised to the power of half. So this is the value of partial of f with respect to x. Now again we will take the partial derivative on both sides with respect to x. So let's do that. So we'll have the second partial derivative of f with respect to x, which will be equals to, we have a multiplied to partial with respect to x of secant squared. So we can write secant squared as secant of y plus ax whole raised to the power of 2. So this is written so that we can apply the power rule here. Minus 3 over 2a times partial with respect to x of y minus ax raised to the power of 1/2. That gives us a times, so we'll use the power rule to get 2 times secant of y plus ax whole raised to the power of 2 minus 1 multiplied to partial with respect to x of y plus, no, we have to take the partial with respect to x of the secant function, which will be secant of y plus ax minus 3 over 2a times, now we'll use the power rule to this expression. So we have half times y minus ax raised to the power of half minus 1 times partial with respect to x of y minus ax. So let's complete the expression. So we have 2a times secant of y plus ax multiplied to the partial derivative of the secant function. So that's, let me write it down here. When we take the partial derivative with respect to x of the secant function, so that's secant of x times tangent of x. So that means we have here partial derivative of the secant of y plus ax will be secant of y plus ax. So this will become squared times tangent of y plus ax. And again, we'll have to apply the chain rule. So we'll get multiplied to partial with respect to x of y plus ax minus, so we are 3 over 2 times half, so that will be 3 over 4 a multiplied to y minus ax raised to the power of negative half, and partial of y minus ax with respect to x will be simply negative a. So that means finally, and this will give us positive a. This value will be positive a. So that means we will finally get 2 times a squared multiplied to secant squared y plus ax plus tangent of y plus ax plus, because we have a negative and a negative a, so we have 3 over 4 times a squared times y minus ax all raised to the power of negative half. So this is the value of second partial derivative of f with respect to x. What we'll do, we'll take e squared as the common factor. We'll have second partial derivative of f with respect to x. We'll take a squared as the common factor. So this will get multiplied to 2 times secant squared of y plus ax multiplied to tangent of y plus ax plus 3 over 4 times y minus ax whole raised to the power of negative half. Now let's set this aside. We are going to use it in the next step. We're going to label this as number 1. So we'll again consider our original function f. Now we will take partial of f with respect to y, which will be equals to partial with respect to y of tangent of y plus ax plus partial with respect to y of y minus ax raised to the power of 3 over 2. So that's going to give us the secant squared function. So we have secant squared of y plus ax multiplied to partial with respect to y of y plus ax plus, well, let's apply the power rule. So 3 over 2 times y minus ax raised to the power of 3 over 2 minus 1, which is half, times partial with respect to y of y minus ax. This gives us, now since we are taking the partial derivative with respect to y, so only y we need to take this derivative. A times x will become constant, so that derivative will be 0. So that means partial derivative of y plus ax is simply going to give us 1. So we have secant squared of y plus ax added to 3 over 2 times y minus ax raised to the power of half, and similarly partial derivative of y minus x will be also equals to 1. So we have now obtained partial of f with respect to y. Now what we'll do, again we'll take the partial derivative on both sides with respect to y, which is going to give us the second partial derivative of f with respect to y, and this will be equals to partial with respect to y of secant squared y plus ax plus 3 over 2 times partial with respect to y of y minus ax whole raised to the power of half. Now here we can use the power rule to get 2 times secant of y plus ax multiplied to partial with respect to y of secant of y plus ax plus 3 over 2 times half multiplied to y minus ax raised to the power of half minus 1, which is negative half, times partial with respect to y of y minus ax. That gives us 2 times secant of y plus ax. So here we have to take the derivative of the secant function, which is secant times 10. That means we have secant squared y plus ax times tangent of y plus ax multiplied to partial with respect to y of y plus ax plus 3 over 4 times y minus ax raised to the power of negative half, and partial derivative of y minus ax will be simply 1. So that means this will also go to 1. And finally we should get partial with respect to f of y squared, so that will be equals to 2 times secant squared y plus ax times tangent of y plus ax added to 3 over 4 times y minus ax whole raised to the power of negative half. This is number 2. What we can do, we can substitute this value with the second partial derivative of y with respect to y into our previous expression. That means in place of this particular expression in the right hand side of equation 1, and that finally gives us the second partial derivative of f with respect to x equals to a squared times, so we can replace the expression within the parentheses with second partial derivative of f with respect to y, or we can simply write fxx will be equals to a squared times fyy in the notation form, right? Hence proved.